Okay, well now let's foreshadow our lives as research mathematicians and take a look at a result, see if it makes sense to us, and then suppose that one of our friends gives us a 2-column proof. Can we convert it into a paragraph proof? Let's see if we can do that right now. So here's the result that we're going to take a look at. So we're given this line segment here, and you can see these marks, P, Q, R, and S. We see that PQ, that line segment, is congruent to RS. And we're asked to prove that PR is congruent to QS. And actually, this makes a lot of sense to me. Let me talk you through my thinking just so you can see how I'm thinking about it. It's so important every time you read a proof like this to first say to yourself, do I believe it and why? Well, if this is congruent to that, I notice that this is congruent to itself. So therefore, if I take this piece and add this piece, that length should be equal to the length of this piece plus that piece. And therefore, since this length equals that length, this segment must be congruent to that segment. So in my head, I sort of see a picture of how this is all going to play out. And it's really important, I think, when you start to look at results, to sort of have a little movie in your head where you can see it play out, even in this case where we're given the whole proof. Doesn't matter. Think about it on your own. You should convince yourself first. Now look at this proof. It's huge. Look at that. Woo, woo, woo. Okay, a little intimidating, but let's see if we can take it and parse it into a paragraph proof. So first, let's go through it really quickly, and then we'll work through it carefully and try to produce sentences. So first of all, we're given this fact. So that's good. Therefore, the length of PQ, that length is going to equal the length of RS. That's just the definition of what it means to be a congruent segment. So that's good. QR is equal to QR. That length, the length of this line segment is equal to itself. That's the reflexive property of equality. Of course, we know that. So that's good. Now, what do? We take the length PQ, this is exactly what I foreshadowed, and add it to the length of QR, and that equals the length of QR plus the length of RS, and that's just the additive property of equality. And now what do? Well, now what I do is I use the segment addition postulate to notice that, in fact, this sum is precisely PR. This plus this equals the length of this whole thing. And similarly, QR plus RS equals QS. So QR, that length plus that equals the total length. That's just the segment addition postulate. That's fine. And so therefore, if we just substitute, we see that the length of PR is equal to the length of QS. And finally, we see that therefore the segments are congruent by definition. All right. Basically, what I just said was the paragraph proof, but now let's say it for real. I'm not going to write it out. I'm going to speak it, but it's all going to appear here. So the paragraph proof would be as follows. Notice there's not going to be 2 columns. I'm going to be saying prose. We begin by noticing that we're given that PQ is congruent to RS. Thus, by the definition of congruent segments, we see that the length of PQ is equal to the length of RS. Next, by the reflexive property of equality, we conclude that the length QR is equal to the length of itself, QR. Applying the additive property of equality, we see that PQ plus QR equals QR plus RS. By the segment addition postulate, we see that PQ plus QR equals PR, and similarly, QR plus RS equals QS. Next, we can substitute and notice that PR equals QS. And finally, we conclude that since those lengths of those segments are equal, we see that the segments themselves are congruent by the definition of congruent segments, period. Now, that narrative actually captures the spirit of this 2-column proof, but it does so in sort of a more literary way, and it does so in a way that is more conforming with how advanced mathematicians actually prove advanced theorems. So you have a little foreshadow into what's to come, as I hope your studies of mathematics takes you all the way. I'll see you soon. Have fun.